So this is section 10.5, and for this section we're using the Pythagorean theorem. So if you recall, the Pythagorean theorem is a squared plus b squared equals c squared. And to use this, what we're going to do is we have to solve these triangles. We have to solve for x. So the two smaller sides are the two legs, or a plus b, or a and b, and the larger side is where x is right now, is the hypotenuse. And the hypotenuse must be larger than the two legs, so I actually noticed that I made a mistake over here. That's supposed to be 9 and 5, since the hypotenuse is always larger than the two legs. But let's get into solving for this. So, since the two legs are a plus b, 3 squared plus 4 squared equals x squared. 9 plus 16 equals x squared equals 25. And then you square root both sides, x equals 5. Now that was really simple. You just have to use the a squared plus b squared equals c squared, and that's all you need to do. And let's move on to the next example. So I'm actually going to move these a little bit down because we're running low on space. But now we have 5, 9, and x. Now x is one of the legs this time, so that means let's just say x is b. So 5 squared plus x squared equals 9 squared. So 25 plus x squared equals 81. Then you do 81 minus 25, which is 56. And then this is where the calculator comes in. You have to square root 56. So I'm just going to do that. 56 square root is 7.483. So x equals 7.5. Or if you want to be specific, x equals 7.483. But this is the final answer for x. Now, at the bottom, now what we're going to do is we're going to check if these numbers could be the sides of a right triangle. So the two smaller numbers, 4 and 6, let's check if 4 squared plus 6 squared equals 7 squared. So 4 squared plus 6 squared equals 7 squared. 7 squared. So we have 16 plus 36 equals 49. And 16 plus 36 is not 72, 52 equals 49, which is untrue. So these could not be a right triangle. And now let's do the last example. So 6, 8, 10. And so we have 6 squared plus 8 squared equals 10 squared. So we have 36 plus 64 equals 100, which, if you add these two together, 100 equals 100, which is true. So this is a right triangle. And when three integers or positive integers are equal to a right triangle, like they can make a right triangle, that they're called Pythagorean triples. So this is a Pythagorean triple. This is not a Pythagorean triple. But we have at the top left 3, 4, and then 5 for x. That's also a Pythagorean triple. But that's all you need to know for section 10.5. That's it.